Okay, so in Revision Village topic 19, the civil engineer is measuring the area of the sloped land, and she uses this device to determine the coordinates of the land, of the corners of the land. So these are the corners of the land. And we're trying to use vectors to determine the area of the land. So we have a formula to find the area of the land if this forms a parallelogram. And so that's what we're trying to show, is that this does form a parallelogram. So for it to be a parallelogram, the opposite sides must be congruent. So you can start by using your distance formula to find the distance from A to B and the distance from C to D, and show that those distances are the same. And then after you do AB is equal to CD, you can also find the distance from A to D and show that that distance is the same to B as B to C. So once you know those distances are the same, then we can say we do have a parallelogram, and then we can use our formula to find the area of the parallelogram. So next we want to find two vectors that form a corner of this parallelogram. So we're going to use BA and BC. You'll need to show how you find vectors BA and BC. So for BA, you should be doing A minus B, A minus B, A minus B. And for BC, you should be doing C minus B. Now you may have chosen a different corner, but you should still get the same answer in the end. So then we need to find the vector product of BA and BC. And remember that that formula is several places in your notes, and it's also in your formula booklet. You'll need to show the steps for finding the vector product, and you should find that the vector product is 0, negative 135, 675. And then after that, we need to find the magnitude of the vector, because the area of the parallelogram is equal to the magnitude of the vector. So you will need to show the steps to find the magnitude of the vector product of BA and BC. You should get that your answer to 3 sig figs is 688 square meters. And make sure you show all of your steps. Okay, in topic 20, you have a golf buggy driving in a straight path, and we're given some parametric equations. X is equal to 2t plus 11, and y is equal to 3t minus 5, where t is the drive time in seconds, and the distances are measured in meters. If you take these parametric equations and rewrite them as a vector equation, notice that the parameter t is in the second position over here, and this is your direction vector. And then this one here would describe your initial position. That's going to help you answer the questions. So to write down the initial position of the buggy, once you have your parametrics rewritten as a vector equation, you can see the initial position is 11, negative 5. To find the position of the buggy after 30 seconds, we're just going to substitute 30 for t. You can do that in either the vector or the parametric equations. When you substitute 30 for t, you'll have 11 plus 30 times 2, and then you'll have negative 5 plus 30 times 3. So make sure that you've written down your steps for determining the position after 30 seconds. The velocity vector of the buggy, once you've rewritten this, you can see your velocity vector right here, which is 2, 3. And then the speed of the buggy will be the magnitude of your velocity vector. So the magnitude of vector 2, 3. And you'll need to show the steps to find the magnitude of this vector. But you should get the square root of 13, which to 3 sig figs is 3.61. And it's meters per second, and remember IB writes meters per second like this.